Hello, this is the fourth thoughts video, but more than anything in this video, I am a little bit concerned that I have not been adequately explaining the broader picture here and the true reason why I think that this is important right now and kind of the situation that is at play within civilization through the lens of historical rise and fall of civilizations and also with regards to the technology that we now have and the trajectory that we're headed on right now into the future. So, just through a lens of history, very quickly, civilizations typically fall on two sides: one through oppression and one through chaos. And oppression is simply when there's just too much centralized power that the people within that organizational structure do not feel like they have a life worth living. It's a little pressure cooker of humans that just don't feel like they have enough autonomy, and they don't feel like they have enough ability to thrive, and they're excited about the future and their family. And this eventually just boils over and unravels. And then on the other side, through chaos, it leads to the same outcome as well. That's simply when there's just not enough coordination in general. There's too little coordination, and there's no common ground, and there's no common goals that people can work towards, and no centralizing force to keep them all together. So it just kind of unravels in entropy here, and we have to be very cognizant of this as we think about our organizational structures of the future, and really where the power centers are right now as we try to navigate this road to our future in a sustainable, resilient, and happy and exciting way for the individuals on planet Earth. So if you think of it's one thing that's kind of interesting is there's kind of both of these things happening right now simultaneously, which is a bit unique, I suppose. So there's real world. You don't have to look even really through history to see examples. Like, you can look at this in real time, and of course there's very obvious examples of the more oppressive civilizations and societies that have a lot more top-down power. And given the exponential tech that we were entering into, given this increasingly exponential velocity towards the technological productivity on Earth, this can be a very powerful force if used correctly. And you're seeing bits and pieces of this for sure. If the leadership of these things can know the correct problems to work on and are quite efficient in their goals, this can be a very powerful force. But history shows that this is not sustainable over the long term, and I suspect most people within civilization do not want to live in an oppressive society where something that limits their ability to thrive and their ability to be autonomous and ability for freedom of action. So we have to just think about this very carefully here, as that is a growing power center, especially as we increasingly enter this technological future. On the other side, of course, we have societies more. This is more demonstrative of Western democracies in general that are falling into this chaos. But it's not any one reason. There are multiple arcs of various things that are kind of not necessarily related, but they are all happening at the same time. And this is one of the reasons why it's kind of difficult to wrap the head around in many ways, because following any one of these arcs in particular is meaningful, sure, but you're lacking the broader picture here if you're not seeing these things all play out at the same time. And I've discussed some of these things, but there's many, many more, and I'd be happy to, but we have to be aware and honest and have true conversations about what these things are. So of course, there's this transition from biological labor and productivity to technological, which causes this whole situation of how do people find their purpose? How do people earn their money? Do people need to earn money? Where is it coming from? And this is all very philosophical and deep in the economics and governance of our cultures. And then of course you have this, because of this inherited resource growth value vector that is no longer appropriate, and when it's being used in the digital arena resulting in this ads model, you do get this inherent lack of like this erosion of sense making. So one way to think about this is, because we, in the past, like this whole representative government thing worked out really was quite successful for a number of reasons, not any one particular, for the last couple hundred years, because you'd have this in this classic capitalist situation, you had this expanding growth geographically and demographically. So as the in the North America anyways, as the Europeans moved westward through North America, there was just this plenty of resource, and there's plenty of opportunity to exploit the land and the growing population to sell to, and all these things. So this allowing resource growth to be your primary and maybe only value vector kind of was useful to solve this, to be successful economically in this situation, when you're valuing each additional unit, each additional thing, that system and service that was being deployed. That was a very successful experiment here as we kind of move over the last couple hundred years. But when you look more at the governance of this whole situation, then you'd have this representative government where you'd have many smaller communities each would have town halls, and they'd have, within the town halls, they'd be able to talk about all the community's issues, and instead of having some binary fight, some you versus me, some us versus them, some win versus loss, some 1 or a 0, that you'd have to have some sort, because you're literally all in a single room here talking about the issues, then you have some sort of a cohesive, connected, and coherent conversation about how everybody can work together and find some sort of compromise, so that you don't actually get to a vote, even, because voting is inherently somewhat of a failure of democracy, because that inherently means that you have somewhere near 50% of the people that feel like they have lost in some way, instead of working hard to find collective solutions to solve problems, and to find it where everybody can be a winner in some way in their mind. And this is extremely important, and was quite successful. And because everybody within these communities and everyone had relatively the same kind of technologies broadly, then there was a lot of the common issues they were felt amongst everybody. So there was underlying things that just held everybody together, whether that's their technology and their socioeconomics, and just their culture and the drive for a better future. And I think a lot of that is still true today. Like, I think humans in general have so many traits and goals and aspirations that I think are common amongst most people. Like, we want the ability to be free, and you want the ability to be happy, and have the ability for your family to thrive, and to be able to explore, and to be able to have the opportunity to develop and build and be curious, and all these things that I think are just quite common. And everybody, of course, wants some standard of we want this infrastructure to give us all these things. But unfortunately, within this resource growth value vector and in the digital arena, which has resulted in this ads model within social media companies, which really do hold a lot of power these days, because it's where the sense making is, the root of the sense making just really holds quite a bit of all the influence, or increasing amount of influence, or whether in the past that was by pigeon, and of course people that were transporting news verbally, and then of course with the printing press being able to do newspapers and books of these things, and and then of course radio and television, and now the internet, in this global connected world at the speed of light, when the information can just disseminate instantaneously to billions of people around the world for essentially free. Then this is a miraculous thing. That it's truly phenomenal what we have here. But when you apply the ads model to this thing, where it's all about capturing the most amount of seconds of attention possible from each individual within the organizational structures, then where that leads obviously is not to collective sense making with some sort of rooted beliefs and rooted foundation in reality. That is not even part of the equation. When it's just focused on maximizing your attention, that kind of goes to the bottom. It's a race to the bottom here, because of course our minds are just drawn to these conflicts and controversy and negative things, and we get riled up and we want to engage more. And this is great for addictive attention, but not for collective sense making. So this is really where the erosion of this whole democracy happens, because when you don't have any sort of collective sense making on things, and there's no grounded truths that anyone can actually stand on and have this intellectual and cohesive and coherent conversation to try to come to collective solutions, then that is where you get in this place where we're at. And it's all about momentum, and it's all about who can garner the most amount of emotional response from the most amount of people around planet Earth. And of course, the people that are really good at this don't always have the traits of being true great leaders and have the best interests of the humans of planet Earth at heart. So we must be very careful when we think about, as we move into this new organizational structure, just what has worked and what is happening and why it's happening more significantly. And so just again, thinking of this clear, like within this organizational structure, then as I touched on this a little bit in the last video, but I'll just dive a little bit deeper to finalize a thought that I missed out on in that one, is when you do have these kind of, as we move toward the technological productivity side of things and away from the biological productivity side of things, then you do get these increasing spires of corporations of power and wealth. And so, and then of course the biological productivity, which is all the humans on planet Earth, eventually have fewer and fewer jobs. So then the question of course comes up, where do these people find their purpose? Where do these people find their means to live? And the usual thing is that, it has to come from somewhere. And the only thing that's being productive, of course, in this whole organizational structure is these massive corporations. So then the corporations would have to get taxed by the government, and then the government would have to be responsible for redistributing this wealth. But just think about the government here for a second, and the incentive structure for the leadership within this thing. Because the governments are a corporation in the limit, there has never been a forcing function for true capital allocators, great, efficient, effective capital allocators to emerge. And we must be very clear about what leadership does in all these organizational structures, whether it's corporate or government or otherwise. Like when you're at the leadership position, your fundamental job is a capital allocator, or one of your most significant jobs is a capital allocator. And when you're within the corporations, you have a forcing function to be a good capital allocator, because if you are not a good capital allocator, the corporation will cease to exist. But within the governments, because there's no forcing function to be a good capital allocator, then you have this thing where you have people that are able to spend more than they earn, and then just tax more or print more or go further into debt, and it's all just kind of like, it's all kind of fantasy in some way, and there's no repercussions here. So when you think about this model where you have these giant spires of wealth and power in corporations, and which gets all, then of course they have to be taxed quite significantly through the government to then redistribute that amongst the people. But the redistribution mechanism there is these poor capital allocators within the government. So that's just the whole thing just is not effective when you're competing against the far greater powers on the other side of this, on the more oppressive side of things. So when you of course the metaphor here with the debt thing is you can just go infinitely into debt apparently, and on this landing on this trampoline. And when you have that ability, and politicians and people within government have that ability to just keep going further into debt, there's no forcing function to be a good capital allocator. So just that whole thing just kind of loses efficiency. And so just briefly touching on cultures on that respect. So then that's why you have this token pulse from the substrate that just comes out at 1 a second, can be divided into 1 billion nanotokens and distributed by the algorithms and that are set by the leadership and the capital allocators of the culture. And if they are providing a guiding light to along value vectors that some critical mass of people believe in, and they have, because of this transparency, you can see how the capital allocation, where the incentive structures are, and they're being efficient and effective at this, then other people will be more attracted to come to this thing and bring their time, ideas, and resources to these cultures that are doing this. And those have a higher probability of being successful. And because they are all transparent and there's a substrate beneath them, this also provides this forcing function for leaders to be honest and to follow through on what they say they're going to do, and to listen to the people within the organization through these transparent polls, and to just set this light and the shining place that they want to go. And what you want is these people to run, to sprint as fast as they can, to be able to compete with the other forces at play here. You need organizational structures to move as quickly as they can. But there needs to be a self-check option, such that if these leaders get too out of control, they get corrupted, or they get inefficient, or they get stagnant, or whatever happens, people within the organizational structure need the ability to opt out. And this is where that substrate comes in. You need the ability to transfer your time, idea, and resources to other cultures. So fundamental. So what I'm trying to get at here is cultures kind of have the best of, try to figure out the best of all things here, learn from the past, and then use this technology that we have to build organizational structures in the future that can enable the best of all things. So the substrate allows the people to then keep the leadership in check, but the leaders have the ability to just be quick, make decisions as quickly as they need, and be bold, and just set the place that we want to go. And if that is not an effective place and no one wants to go, then they won't be successful. And instead of just bouncing into this never-ending depth of a elastic trampoline thing with debt, the token value just goes to zero and they'll fizzle out. And when you think about this evolutionary expanding branch of cultures, you just cultures can copy from each other because they're all transparent, and they can take everything from within the existing cultures of software and organizational structures and constraint ledgers and distribution algorithms and projects of all the intellectual output that has come from any culture. Just take it totally open source for free. And then if you provide a more strong vision and you're a better capital allocator, you're making progress faster, and you can take everything and do it your own way. And if people bring their time, ideas, and resources to your culture, then you'll be more successful. So, and this is just how you accelerate this conscious evolution thing while being able to keep the leadership in check and not run away into some situation where you fall into the oppression. Because again, on the other side of this thing, you have this leadership's organizational structure that has very top-down control that can be quite efficient if they are again good at resource allocation and understand the true problems to work on. And this is being demonstrated. So we just must keep these two things in mind. And just briefly to cap out on this on the culture thing, and this slowly kind of easing into culture earth here a little bit. When you have organizational structure that is taxing corporations, going through a government, and you're just handing money essentially to people, but not fixing the underlying, the rotting infrastructure below them, the rotting systems below them. This is a very unstable situation. So what cultures can do, and what Culture Earth would be focused on, is really focusing on that. Instead of just handing out money to people, you build the attractive you build this attractive thing that people want to be a part of, and really just think about this. And this is why I keep coming back to the pillars of civilization, because if we can really set the incentive structures to build the pillars of civilization, then you get to this point where there's something tangible that people want to go toward. And there's something real, that there's a solution to these things. Because if you don't solve the pillars of civilization, you'll always be dependent on the current organizational structures to provide the pillars of civilization. And when I talk about pillars of civilization, I just mean what in your life can be taken from you and doesn't matter. right? Those things are negligible in the end when you really think about it in the limit. And then what things can be taken from you that really do matter, that things just devolve into chaos when they leave you or your family or your community. And so from my reasoning, I would say that this would be food and water, this would be energy, this would be movement, this would be communication and shelter. And through these things, through the combinations of these pillars of civilization, you can do other, then you bring in other very important things like educating your people and all these things. But like, these are the roots of this whole situation. So this is why this is why Culture Earth is just vigorously focused on the pillars of civilization in this way. So I'm going to touch on energy a little bit here, because I think energy is maybe the deepest root of all pillars of civilization, because from that, then you spawn out and you're able to, again, go to to spend that, distill ocean water and pump it through with electric motors through pipes around civilization. And then that energy then of course powers these light pulses through the fiber for communication, and it allows us to have these indoor farms that have infinite amount of light and environmental conditions to grow whatever you want, and you'll be able to push around your vehicle, your autonomous electric vehicles and aviation and shipping and things of this nature. So and of course and then have other machines and power the digital productivity, which is the digital mind in the computer form and the neural network thing, and then of course the power in the digital muscles and electric motors and transport and like humanoid robots of all kinds, and as we move into the future here. So this is why energy is a very important one, and just discussing a little bit on why Culture Earth, like how we have the highest probability of success. You need the ability to have grounded truths in decision making, and this, of course, as proven in history, this needs to be grounded through the scientific method. Has proven to be the most effective way to do this. And so through using like physics, essentially in this, especially when you're figuring out the efficiency of this situation, you want to maximize your efficiency to increase the probability of success of being able to provide these, to get humanity to this place where you have the pillars of civilization in a fully sustainable, fully resilient, zero marginal cost way. And this is, if you can do this, if a organizational structure can do this, where the people aren't being oppressed and there's not chaos, but there's the incentive structure, like the organizational structure, the value vectors, and the incentive structure within this organizational structure are aligned along value vectors that people believe in and are getting these pillars of civilization to the people, for them to give the people the best ability to thrive, to be free, to learn, to pursue new things within their life, and to just enjoy this world in the maximum amount of way we can. Because this is what, at the end of the day, this is what I think life should be. I suspect people would want this. We have this beautiful world and this amazing, we're just thing that we're somehow all a part of. And so wouldn't we want to have all like the conundrums of being able to support this, at least at the pillars of civilization level, so that you can go on to do other things and think about we'll do like collaborative things and beautiful and biological ecosystems for us to live in, and social collaboration and just like and inquisitive, curious endeavors to just keep on finding purpose for humans and enjoying this whole thing and enjoying the time with your friends and your family and your environment. So this is what Culture Earth is. It feels like that is what is needed to be an attractive force into the future here, an attractive thing that people want to be a part of, not being forced to and not whatever, but just being the voluntary attraction to this thing. But we must figure out the pillars of civilization to do this, and you must use a scientific method to figure out the most efficient way to do this, because the more efficient, like the more sustainable and efficient you do this, then the higher the probability of success of this whole thing is. So just very at a highest level, efficiency is simply like the use, like it's this little division thing. You have the useful output energy divided by the total input energy. And this is, I'm going to be using this word a little bit in the next few minutes. So like joules is the SI unit for, is like what's a well-used unit, the common unit used for energy. So you want to have the least amount of you want to have the most amount of useful output joules with the least amount of input joules, with the least amount of input energy. And this will give you some ratio. And you want to maximize that ratio. Do everything you can to maximize that ratio. And so we're just gonna bring it on energy. This can be applied to all things, but let's just chat. Like I'll finish up this thing, I think, on energy here. So again, mostly like all energy in our situation, like in our local solar system or whatever, is primarily from the sun. Of course, you have this embedded energy within the earth, this heat energy stuff. But most of the energy that is useful to humans on planet Earth is all from the sun. So that's where you start your efficiency equations from. This is just like start at the sun. And then from there figure out, okay, how many joules from the sun needed to go into this process to get a useful joule out, whether that's moving your car, heating your house, powering on your phone, sending a message through the fiber, these kinds of things. So let's briefly dive into like fossil fuels here just for a brief second, because this is quite eye-opening when you do this situation on this efficiency calculations within fossil fuels. And I really encourage people to do the math as well. Don't take my word for it. Just grab a piece of paper and we can even do it together someday. But we need to. This is fundamental for how the decisions are made. Like if you're given multiple options on energy or housing or what molecules or atoms need to be aligned in which way or whatever. This is how you to be most efficient and to increase the probability of success of having this thing that we can all build together. We must do the math, and we can do it together if we all want. I mean, as many times as we all need to do this. But this is how you solve these. This is a huge guiding principle as how you to determine the efficiency of all these things. And you can think of this as well. Just a brief tangent. You can think of this as in a couple of different, of course, there's the amount of input, like the energy efficiency from the sun, but there's also this kind of indirect thing that is also technically from the sun, but how much biological energy is going into this thing, when that would just being human capital. So as we're thinking about different processes and manufacturing and energy generation and distribution and these things, how much human capital, which is biological energy, biological joules, have to go into this process as well, because we're clearly like the people, like the organizational structures that leverage this technological productivity will be most efficient. So we want to get there, and of course this will mean that we don't have like the standard 9 to 5 thing, but you have to completely move into the new realm of thinking where you're going to 100% technological productivity, which frees up humanity to do all these other things. So you don't need it. So like the trap of the existing situation in our current organizational structure is that even as we're moving into, this is another one of those tangential arcs I was talking about. Like even as we're moving into the technological productivity, because in this current organizational structure where if the people don't have the jobs and they can't do well in this whole organizational structure, then we artificially create inefficient processes that require biological productivity just so that they can maintain their jobs. But this will not be successful versus other organizational structures that do not use that scenario. And these are happening anyway, just in parallel. So you have to accept this reality and really but instead of it being a negative thing for humanity, we can make it a positive thing for humanity. So that's like, so when you're thinking about this efficiency to get to the pillars of civilization for zero marginal cost, fully sustainable, fully resilient, also consider the biological productivity that's required to achieve this. So fossil fuels. Okay, so like you have joules that are coming in from the sun, and this kind of goes into plants and animals, and they eventually die, and then hundreds of millions of years goes by, and this like eventually gets deep in the Earth's crust, gets compressed and heated, and eventually turns into this. You get these various fossil fuels that are deep embedded underground. And honestly, even if you just like cut it there, just like forget everything, that whole process before that, even if you just cut it there and take the efficiency metrics, take the efficiency calculations from the time that it's mined out of the or extracted out of the ground, it's just like still this catastrophe. So anyways, from there, of course, it gets either pumped out of the ground or it gets mined out of the ground, and then it gets transported and it gets extracted and processed, and then it gets transported again through trucks or pipelines, and then it goes through some final situation, whether it's combustion, usually in some sort of form, in an internal combustion engine or turbine or a gas turbine or industrial process of some kind. But think about all the way along that thing, that how many joules of energy had to go into the extraction, how many joules of energy had to go into the transport initially, then how many energy into the processing, and joules into the transport again to the final, and then finally into this combustion situation, where most, of course, is expelled as like in combustion, most energy is expelled as heat. And if you're not in this like a system that's trying to use heat, then it's just completely wasted. And anyways, just trying to show you on that we won't do all the things here, but just take that, like follow the energy is important here. Follow the energy, and that useful joule that was used to heat your house or whatever, bring that all, like, where did that start? Take it back, like just like turn everything in reverse, take it back through the whole process all the way to when that joule was just like hanging out in the Earth's crust somewhere, and then how many joules had to be applied to that joule. This is kind of like a silly metaphor, like a silly thing to think about, but just think about it. That's one way to think about it. How many joules had to be applied to that to get that useful joule out. This is what I mean by efficiency. And so in this whole process, in the fossil fuel thing, it does not pencil out well. It's been, of course, it's very energy dense, and this was a huge thing that we needed for civilization to get to this point, because of and for us to advance the civilization, to allow us to build the technology to get to the next level of to build the technology that would allow us to have sustainable energy and do this far more efficiently. So this is not it's not bashing fossil fuels out here at all. So fundamental to everything that we have right now. I think we should be applauding everything that's happened for us, but continuing to rely on fossil fuels as we move into the future, and when you have more efficient technologies at your fingertips that are also just amazingly fully renewable. If you do not adapt to your changing environment here, this is not a good thing. This is look at history, and those that, if you don't adapt, then this is where things just do start eroding and falling into chaos, and entropy kind of takes over. So, and even, I mean, just apply this to all molecular energy forms, whether like through that's natural gas, or that's coal, or that's like oil and petroleums of all kind. But even in like with this hydrogen craze, we must apply this exact same formulas on this new craze for green hydrogen thing. Arguably, there's even it's worse in many ways. I mean, just like the amount of energy that has to go into separating the hydrogen, like you're separating from water. You can do it various ways, but if that process, if you're wanting to separate water, like H2O, into hydrogen and oxygen, that's the energy intensive process. Then when you get this hydrogen, usually it's like a very pernicious little thing. And it's trying to like escape. It's a very small little molecule, so it's trying to escape through all the cracks, and you have metal embrittlement, and it's because it's so. It's not dense, so you want to keep it very cold to be more dense, and that applies energy. And then you have to push all these molecules, regardless of what the molecule is. Like you need the pumps to push this through, and just the energy to go through here, just crazy. So now just compare this now in using these same equations to when even just on the distribution of the energy, when you're trying to push a molecule through a pipe versus excite these little electrons through this very high voltage line. This is fundamental too when we kind of are considering how we transfer our energy, or even what energy to use in the first place. So again, you can do the math here. When you are the amount of joules that have to go into pushing that embedded joule through a pipe to go to some power plant with natural gas or whatever, that you have to be very clear about how that, like, the amount of input joules that are going into that process versus an electric line that just goes a super high voltage. Like the energy density of the power density that goes through and right now we're doing like 500,000 million volts. Just like if you do underground and go just massive on the voltage, those electrons are just going crazy. Like just at the speed of light, you can send that joule through that cable, and the power density is just like unbelievably far greater, and the efficiency on this is just unbelievably far greater. And then just again on this on the using the molecules thing, and even nuclear in the power generation sense, essentially all you're doing is just creating this like little hot thing to boil water. So, which is like kind of the same as like the steam engine era, which is somewhat hilarious. So we just like, you generate this heat through combustion of fossil fuels of some kind, whether it's natural gas or coal or oil or whatever. Or in nuclear, you just have this little fission reaction to generate heat, and then that boils water, and that steam then goes through a turbine and generates electricity. So that whole process has to be considered as well when you think about this. And so now, just like not bashing the fossil fuels at all. Let's do this exact same processes on renewable energy. And as I said in a previous video, like when you have moving things in your design that are rotating or oscillating linearly or whatever, like you have little actuators, whatever's happening, moving things in design that are working, that have a high cycle life will fail earlier than things that are static. So again, we can do analysis on all this stuff in physics and in engineering to understand these things together. But you want static mechanisms if they can do the job efficiently and in a static way. You always want to delete the moving things. So when you have these wind turbines and you have hydro turbines and you have these like geothermal pumps or whatever, always have a lot of moving parts to them, and it's just how many, which, and these things fail. So then you need the biological productivity, like being humans, which require joules and money and whatever to then go and fix these things constantly. And then you have to build the parts to fix this, and the whole thing is just. Again, I think I just want to make sure I'm clear that you don't remove these things from civilization and just like let them carry on if they want, but when you think about the physics and the efficiency as we move forward and get to the next order of magnitude of energy that civilization can have, like, of course, you can go nuts with energy when you have a zero marginal cost production. But I mean, of course, you want to be as efficient as possible, but if we need it, we can do it for zero marginal cost. And just roughly on the current global energy front, it's very simple. If you just to keep it as simple as possible, roughly, you can divide Earth very roughly into thirds on energy use. 1/3 electricity, 1/3 heating and cooling, and then 1/3 transport. Very rough, but that's roughly where it is. And both heating and transport, due to efficiency, will be moving into using electricity, even on the end use part of things, not on the generation, but on the demand side. When you compare electric motors versus internal combustion motors, it's not even a competition. Like this, the efficiency is so much, the amount of joules that have to go into this movement process to get useful work out is far more efficient with electric motors. That's why like all of transport will obviously go electric. And then in the heating thing, these more advanced heat pumps, the amount of joules that have to go into this to get useful heat out or cooling out or whatever, or lack of removing heat from the system, then it's just far more efficient than doing this with typical fossil fuel heating situations through different furnaces and that kind of stuff. So anyways, both the other 2/3, so the like the transport and the heating will go also electric. So then you'll kind of get this whole thing will be electric. And then right now, just on the and then of course, then we can, so you'll get at least like 3-ish times more electricity demand. And then when you have, but really, if we need a bunch more electricity for other things for these indoor renewable farms, or for more movement of some kind, or like more whatever we need, like more compute for sure by a lot, then you can do this for zero marginal cost when you have a static and very sustainable and efficient generation of renewable energy. And then so just focusing again on the electricity front, the electricity third right now, where it's roughly, like very roughly, you can think of North America consuming about a terawatt of power, and then that's roughly 5 petawatt hours of energy per year. And then globally, just multiply again roughly by 5. So it'd be 5 terawatt hour for 5 terawatts of power and 25 petawatt hours of energy. And this, of course, we'll get more efficient in some ways, but if we need it, we should be able to have, again, as much energy as we possibly want, if we can get it at zero marginal cost, and then distribute it through these underground conduits through civilization. And of course, connecting renewables as well. So yeah, so then bringing it back just to completing on the energy efficiency side, when you're generating, if you can generate renewable energy directly from the sun into direct current in a DC with no moving parts, this is where this like photovoltaic panel is just this clear, efficient winner. No feelings here, not a qualitative analysis, just do the math. And so when you have these photovoltaic panels, then it's really, this should be applauded more too. This innovation is just miraculous how we got here. And again, it could be argued that because we had this fossil fuel energy in the past, that we were able to, society and civilization and our systems and structures, we had the ability to be more innovative and solve this thing, so that we got us to this point. But just now we need to adapt and adopt the newer technology. And so we have to keep doing that as we move forward if we want to be effective. Like, as we don't just cling on to the past because that is like sentimental or beneficial somehow. We need to keep moving forward. And that's why this new organizational structure, it's not about intellectual property, it's about intellectual output. So that as soon as an idea or design or process or whatever has been developed, that is then you get rewarded for that innovation or that move into the next thing. But it's because it's transparent and open source, it is therefore a commodity of a commodity of the community, and therefore free, and therefore no cost. And then that allows the incentive stream of tokens then to go and incentivize the next idea. And so you move from intellectual property to intellectual output. And this is, again, a fundamental thing if we want to go as quickly as we can on this thing, on this innovation curve. Focus on that first derivative of the progress function, and not the integral. Like, you need to incentivize. You need this competition, and you need the ability for some people to do better than others because through this competition, but not through intellectual property and this resource growth value vector that then promotes the clinging on to ideas that benefit people. And had one good idea that made sense a century ago, or 50 years ago, or a decade ago, or a year ago, but no longer makes sense as we try to evolve that idea. But the forces at play, as soon as you have this intellectual property thing within this resource growth value vector, there's too many forces. The mind is just trying to do well, which people should do well, but the organizational forces the people that want to do well to do behaviors that have on net negative outcomes for humanity, not positive. Of course, there's positives along the way, but you don't want to hold on to. You don't want the system to encourage the clinging on to old ideas, clinging on to the past. We want to just keep moving forward as quickly as possible so we can compete with the other forces at play here and try to create an organizational, but instead build organizational structure from the get-go that's compatible with the future and not unsustainable and volatile and dangerous for the future of humanity and the light of consciousness. So just back to back to the electricity. Just I'll finish this off on DC on these photovoltaic panels. So they create, again, so this is an amazing technology. We need to adopt this now to move into the next, to get to this fully sustainable, fully resilient, fully zero marginal cost on energy, which is again the root of the pillars of civilization, like the deepest root. And then what's kind of brilliant here somehow is that it just all works out so well, is that because you have this nothing moving is static, and you're just like have these little like electrons, this p-n junction situation, and these little electrons racing around, and you generate direct current, DC, and that's the most efficient way also to transmit energy. So you go super high on the voltage, like way high on the voltage, and then those electrons just go nuts through that, like again at the speed of sound, or sorry, the speed of light through those copper or aluminum cables. And then when you're going into the areas that are on the demand side, then you kind of get to this place where you can use the direct current as well. Like if you can just stay DC direct the whole way, because every time you convert that energy between direct current and alternating current, like DC to AC, or especially through from fossil fuels of some kind into electrical energy through this process I was talking about, through like heating up the water situation, like that whole, or even if it's just like the direct, like fossil fuels burning with the internal combustion engine and spinning a turbine or whatever, it's just the efficiency, the conversion of the energy between forms is just very, very inefficient. So if you can stay in the single form the whole time and just raise your voltage and lower your voltage on the way down the slide, then that is a situation that maximizes the efficiency. So we need to focus, like just to try to put a lasso around this thing and let it go. We need to focus on vigorously on the efficiency of the processes here to get to zero marginal cost on the pillars of civilization. This is just very, very fundamental for for being competitive here, and for being able to provide this attractive thing that people want to get involved in. I could be wrong, but please, this is the whole point of this thing. Please tell, the whole point of this is to get people talking about this, and get people building on this and iterating on this, and bring more ideas to this, and maybe do phase shifts, and then bifurcate, and then don't want one culture, you want many cultures all competing. And when you have these many cultures, again, you're not forcing people that just fundamentally don't have the same belief system into the same fork, into the same culture, into the same branch. Just let them be free, and the cultures cultures can each have very individual belief systems and whatever. And the ones that will be successful, the ones that show true leadership along value vectors that people truly believe in, that are very efficient in their token allocation, and just provide this light and this dream of where humans want to go on this beautiful planet to enjoy it. And again, just get to this place where we can have this sustainable, resilient, and zero marginal cost pillars of civilization, so that we can then focus on the next things that humans want to do, and whatever that is, then we are just free to do this. So I feel like this is something like deep inside of my heart and my soul. This feels like something that feels right. It feels like the direction that we something we want, that we should fight for, and something that we should build together, and we should work extremely hard to get to something like this for humanity, because we can do this.